5.4, the fundamental theorem of calculus. So here the theorem for the fundamental theorem of calculus, it says if f is a function, if a function f is continuous on a closed interval from a to b, and big F, which would be the antiderivative, big F is an antiderivative of f on the interval, the closed interval from a to b, then the derivative, or I'm sorry, the integral from a to b of f of x dx equals f of b minus f of a. Okay, so remember that this whole thing here, okay, is equal to what we did in 5.2, where we took the limit as n goes to infinity of the summation when I is 1 to n of f of c sub I delta x. This is sigma summation notation. This is just a big S. So this is a shorthand of this. Okay, it's kind of like when we learned the definition of the derivative using limits. It's a big long process. Same thing here, and then we learned shortcuts. That's what this is. This is a shortcut. So let's look at this. So we've got the function f of x here. Okay, and if we integrate it from a to b, okay, f of a would be this area. F of b would be this area. If we wanted to find the area underneath the curve, which is just in here, we do f of b minus f of a. Okay? So let's try one of these problems. So let's look at this problem here. First of all, let's find the antiderivative. So notice the antiderivative here would be the antiderivative of x squared would be x cubed over 3 minus 3x, and the limits of integration are from 1 to 2. So now, to figure out this answer, this is known as a definite integral, because it's you're going to get a number here, where if you don't have these numbers here, then it's an indefinite integral, and you wouldn't get a number, you'd get a family of functions. So the first thing we're going to do, we're going to plug 2 in for x into this, into the antiderivative, so it's going to be 2 cubed over 3 minus 3 times 2 minus 1 cubed over 3 minus 3 times 1 . And let's see here, 2 cubed would be 8 over 3, minus 6 would be minus 6, minus 1/3 minus 3. So let's see, 8/3 minus 1/3 would be 7/3. And -6 minus a -3 would be like +3, so this is going to be -3. And then this would be 7/3 minus 9/3, which would be -2/3. All right, let's compare that with this. So here's the function, x squared minus 3. There's the function right there, x squared minus 3. We're going to integrate that from a to b, where a is 1, b is 2. The area underneath the curve would look like this. So the reason why it's negative, we have more area underneath the x-axis than we do above. So you add these two areas, one's positive, one's negative, and then you get the negative 2/3, which that's what that is equivalent to. So you can't have negative area here. Basically, it's just telling you that you have more area underneath the x-axis than above the x-axis. Let's look at b. So first of all, to integrate this, I'm going to rewrite it, the integral from 1 to 4, 3x to the 1/2 power dx, so with respect to x. And then if I integrate this, this is going to be 3 times x to the 3/2 divided by 3/2 from 1 to 4. And then this would be 3 times 2/3 x to the 3/2 power, 1 to 4. Here, 3 divided by 3 is 1, so this is going to be 2x to the 3/2. And now we can plug in our limits of integration to calculate this. So this is going to be 2 times 4 to the 3/2 power minus 2 times 1 to the 3/2 power. So take the square root of 4, that's 2. 2 cubed is 8. 2 times 8 is 16. Minus 1 to any power is 1. 1 times 2 is 2. So this is going to be 14. Look at C. Okay, so to integrate this, I would start off by thinking about all of the derivatives of trig functions. Okay, we can stop here. The derivative of tangent of x is secant squared of x, so the antiderivative of secant squared of x must be tangent of x. So this is going to be equal to tangent of x, and we'll integrate this from 0 to pi fourths. So I'm going to do tangent of pi fourths minus tangent of 0. So this is going to be 1 minus 0, which would be 1. All right, let's do example 2. Okay, evaluate this. Okay, to evaluate, it's really hard to take the integral of an absolute function, absolute value function. So I'm going to say, let's go, let f of x equal the absolute value of 2x minus 1. And then let's let this equal a piecewise function where x, 2x minus 1, that's going to be when x is greater than or equal, well, let's do this. Okay. So let's first of all, start by thinking about the vertex form for absolute value. So if I had y equals a times x minus h plus k, the vertex would be h comma k. So for our problem, f of x, I can factor out a 2. This would be x. If I factor out a 2 from 1, think about what would I have to multiply 2 by, so this would become 1. This would be 1/2 plus 0. So now the vertex here is going to be 1/2 comma 0. Okay? So if you think about the absolute value equation, one part of it is going to be 2x minus 1 when x is greater than 1/2. The other part is going to be negative 2x plus 1 when x is less than 1/2. Okay? So the answer here can be positive or negative. That's all I'm doing. I'm taking 2x minus 1, that's multiplying it by positive 1, and I'm taking 2x minus 1, I'm multiplying it through by negative 1. Okay? So hopefully that makes sense. That's kind of a review of college algebra. But now let's graph this. So if I graph this guy, okay, I'm gonna start, the vertex is gonna be at 1/2. And when I plug 1/2 into this, I'm gonna get 0. Oops. So 1/2, 0. When I plug 1 into this function, I'm going to get 2 minus 1, which is 1. When I plug 2 into this function, I'm going to get 4 minus 1, which is 3. 2. When I plug negative 1 into the function, I get negative 2, negative 2, negative 3, and the absolute value would be positive 3. When I plug 0 into the function, I get negative 1, and the absolute value would be positive 1. So it's going to look like this. Okay? So now what I'm going to do, I just care about this part of the graph. I want the area here and here. Oh, I guess to 2. Alright, so I'm going to set this up this way. I'm going to take the integral from 0 to 1/2, and from 0 to 1/2, that's this part of the function. And then from 0 to 2, that's going to be this part of the function. Okay? The next video will integrate this.